390.6 divided by 12 is equal to 15.361. Again, how do you know that this is correct? If you substitute y is equal to 3.3, the whole equation should be equal to 0. So 167.281 minus 50.361 times by 3.3 squared is equal to 2.9 times 10 to the power minus 12, very small, so it's equal to 0. So we know that this is correct now. Okay. So the next thing we are going to consider, let me copy the whole thing and we go to another page. Okay. So the next one, we are going to determine 0 y to 3.3 inches. Oh, no, 3.3, 0.3 inch. And then now your thickness is equal to 4 inches. Okay. So now the area of interest is this area of interest. However, the first moment of area or the analysis direction comes from where? From the maximum. So you also have to consider this entire area over here. Okay. But the entire area is a constant because of the limits. So now your y variable now is moving down here now. Okay. And it will peak at 0.3. So your Q now, okay, will be equal to Q of the flange plus by Q of the web as a function of y now. Okay. So this will be equal to the width is 12, the depth is 3, so the whole thing is 3.3 minus by 3 divided by 2, right? So this is your y bar. In fact, we have this value already. I was just doing it again. So the Q web, the width is 4, the depth is 0.3 minus by y, and then 0.3 plus y multiplied by half. So all you need to do is remember the plus and minus down here, and this 0.3 is based on the maximum value down here. Like down here, this is 3.3. This is based on the limits, upper limit. Okay. So this will come out to be 3.3 minus 1.5 times 12 times 3 is equal to 64.8. I think we got this value before, but I know I just calculate again. Times by 3 times 12, 64.8 plus by 4 times 0.5 times 0.3 times 0.3 times 0.18 minus 12 times 0.3 times 0.3 times 0.5, 0.18 minus by 4 times 0.5, 2y squared. Okay. So this will be equal to 64.8 minus by 0.18 is equal to 64.64. No, 64.8 plus by 0.18. What do you mean? 64.98. So 64.98 minus by 2y squared. So from here, what we do now from here is we can immediately determine our shear stress, okay, at y. Okay, so this is against the same. Now the thickness now is 4. Okay, so 64.98 minus by 2y squared. Okay, so 12 power 3, that's 64.98 divided by 390.6 divided by 4 is equal to 499.078, and this number looks familiar, isn't it? Minus by 12 power 3 times 2 divided by 390.6 divided by 4. 12 power 3 times 2 divided by 390.6 divided by 4 is equal to 15.36. Okay, 15.361 y squared. Now, to check whether this is right, Okay, or not to check, because the question asks us to determine the shear stress distribution equation, right? So you also have to do the bottom part. Okay, so now we're going to deal with the bottom part. So again, I will have our centroid, right? So we're going to deal with the bottom part. So the bottom part, we know that, right? So we know that this distance from here to here, I think it's 5.7. Let me check. Can't remember now where we found. Yeah, 5.7. Okay. So now you find, we determine your Q is equal to the width is 4, 5.7 minus Y, 5.7 plus Y, and then we multiply by half. Okay. So this is the range is 0, Y, or minus 5.7 to 0. Okay. So this will be 4 times 5.5 times 5.7 times 5.7 is equal to 64.98 minus by 2y squared. And you realize that both of these equations are the same. Okay. And then finally, you calculate your distribution. So 64.98 minus by 2y squared divided by 390.64. So this is exactly the same like above. We have 499.078 minus 15.36 1 y squared. I think it's 390.390.65. Yep. Okay. Now, so when you sketch, how does it look like? Okay. So we are going to sketch. Okay. So when you sketch, what should be drawn? Okay. So usually the question will ask you to sketch and label. Okay. So you have to do it properly. Okay. So you have more on the bottom bit. So this is 1, 2, 3 inches. Okay, I know you have 3.3. So let me move this down. So this is your Y. This is your 1, 2, 3, 4. And then this will be your minus 1, 2, 3, 4, 5, 6. And it was 5.7. Okay, so this is your shear stress. And from our calculation, we realize that the maximum shear stress is at 500. Okay, PSI. So this would be 100, 200, 300, 400, 500. Okay. And where is our 0? This is where we have our centroid. Okay. And then we know that we have down here is our 0.3. Okay. So this is our 0.3. So from 0.3, right? And then the bottom part is 5.7. So we have our 5.7 over here. For example, 5.7. So we know at 0.3 to 5.7 is a continuous graph that looks like this. This is just a sketch, okay? And then at this point, is equal to 499. What was it? 499.078. So you label 499.078. This is 0.3. Okay. And then we know that there will be a step, right? There will be a step, and where the step stop, that's where you have to calculate. Okay. So we know that if we look at the previous equation over here, this one, we're going to substitute, right? Because this is 0.3. So we're going to substitute 0.3. Y is equal to 0.3. So it's equal to 167.281 minus by 15.361 times by 0.3 squared is equal to 165. Okay, so the shear stress is equal to 165.898 or 899. Okay, I'll do it again. 167.281 minus 15.361 times 0.3 squared. 165.891. Okay, so 165.891 is somewhere around here. Okay, 165. Okay, so it will be a step, right? So you label this point as 165.899 and 0.3. Okay, and then from here it will go to what was it? What is the top one? The top one is up to 3. Is it 3.3? I can't remember now. Yeah,
I think it's 3.3.
3.3, right? So 3.3 is around here. So this is how you sketch. And we know that this is 0. Okay. So these are the critical point. By right, you have to calculate these also. Okay, so to calculate that point is not difficult. So you just need to substitute into this equation over here. You just need to substitute into this equation over here, right? So you just put that. So you calculate that. You substitute y is equal to 0.3. So it's equal to 499.078 minus by 15.361, 0.3 squared. Okay. So 15.361 times 0.3 squared. 499.078 minus by that value is 497.696 in PSI. Oh, sorry, the first value, this one should be 0. I beg your pardon. And this is 497.696, 0.3. Okay, so that's how your sketch look like. And then you write down the equation over here is 499.07 or your shear stress equation is equal to 499.078 minus 15.36 y squared. And this over here correspond to the other formula, which is this one. Okay. So I hope that's all I have now. Okay. I hope by doing this example is a good revision for you. Okay. Especially this cover everything regarding shear stress. Okay. And any other question?
Yes.
Yep.
I am curious. If say this was 1-to-1 one of our exam questions, after we had figured out the two formulas on top, would we be okay just by observation to not calculate the second half, like the bottom?